Hi guys, today we're going to be looking at lesson 5. Our main goals for today are to find two constants of proportionality for a proportional relationship and to write two equations that represent a proportional relationship described by a table or a story. For today's lesson, you're going to need to get your copy of your guided notes, so make sure the top of the page says 2.5. You're also going to need your math book on page 141. You'll need a calculator and a pencil. Please pause the video to get those things now. Starting with our notes, we're going to start in the fill in the blanks. Jay runs 8 laps in 5 minutes. We're going to use the variable L for laps and the variable M for minutes. He divides 8 divided by 5 and gets 1.6. So he knows one of the constants of proportionality is 1.6. But he doesn't know if the equation is M equals 1.6L or L equals 1.6M. Fill in the blanks with the correct values and then determine which is the correct equation. Okay, so the two numbers that we have in our problem are 8 and 5. 8 is laps, 5 is minutes. So when I look at my first equation, I have an M first. So I'm going to look back at my problem where the M is, that's the 5. So I'm going to put that right there. And then the L in the other part of the equation is going to be the 8. Okay, so I have 5 equals 1.6 times 8. The reason that I'm using parentheses to show multiplication is because if I use an x, that might get confusing in a different type of problem where we have a variable that is x. So we're going to use parentheses from now on to show multiplication. And now I'm going to just solve this. So 5 is going to stay by itself because there's no other numbers with the 5 on that side of the equal sign. And then on the other side, I'm going to multiply 1.6 times 8. And when I put that in the calculator, I end up with 12.8. Let's look at the other equation, L equals 1.6M. So L, again, when I go back to my problem, is going to be the number 8. And M is going to be 5. Notice that I put it in parentheses because we're going to be multiplying. Okay, 8 is by itself on the left side of the equal sign. And we're going to multiply 1.6 times 5. To get 8. When we look at the results here, let's go back to that first equation. 5 equals 12.8. That is not a true statement, so this is not the correct equation for this problem. When we look at the second equation, you see that 8 equals 8. So this is the correct equation for this problem. Let's try this with an example. So when we write an equation for each table, well, let's look at the table first. This first one says drops of vanilla, which has the variable V, and cups of sugar, and we're going to use the variable S. Okay, well, first thing we need to do when we write an equation is to find the constant of proportionality, which means we're going to use y over x. Okay, well, which column is x, which column is y? That we're using V's and S's now. Okay, here's the cool thing. No matter what variable we use, x is still going to be on the left side of a table, y is going to be on the right side of the table. Again, think of an alphabet, of the alphabet. So x, y, z would come after it, right? It's in alphabetical order. So now I know that I can find y over x, and I can take 3 divided by 11. I could put that in a calculator and get a decimal. Okay, but sometimes it's easier to keep it as a fraction. So instead, when I write my equation, I'm going to write S equals 3/11 V. Here's my constant of proportionality, y over x, y over x. The reason I'm not using y equals kx is because we need to use the variables that they give us in the table. So instead of putting y, I'm going to put s. That's why s is right here. Instead of x, I'm going to use v, which is next to the constant of proportionality. So this is the equation for this table. When we look at the other table, it looks almost exactly the same, except that the two columns switched places. If the columns change places, do the X and Y also switch? No. X and Y still stay in the same place. X is going to be the left column, Y is the right column still. But what happens to our constant of proportionality? If I take Y over X, what happens? Y over X now has 11 over 3. Look at that compared to the other equation. What do you notice about those two fractions? These two fractions are reciprocals, okay? So every table has two equations. So this one table, I could have written the table one time, and I would have had these two equations for it. When we write the second equation, we take the reciprocal of the constant of proportionality. Okay, so the reciprocal just means that the values on the fraction switch places, but the variables also have to switch places. Okay, notice that we had S over here on the left side of the equal sign. It's now V on our new equation. So if we switch the fraction around, we also have to switch the variables around. Let's try one more example. If you know one of the equations for a relationship is y equals 4/7 x, what is another equation for the same relationship? Okay, so we have one equation. How do we find the other? Take the y over x, or your constant of proportionality, and flip the number around. So instead of having 4/7, I end up with 7/4. But because I flipped that fraction around or made the reciprocal of that fraction, I also have to take the x and y that are in the equation and switch them around too. They're going to trade places. So x is now on the left side of the equation, y is now on the right side. This is the second equation for this problem. Okay, so now you're going to practice a little bit in the book. Go to page 141 in your math book and watch the next video.